Hello, everyone. Today, we're going on a journey to the very rooftop of the world. We are going to uncover the story of the mightiest mountain range on our planet, the Himalayas. It's a truly epic tale of colliding continents and ancient seabeds that rose up to touch the sky. So let's begin this incredible story. It's a fascinating question, isn't it? The highest peaks on Earth, covered in ice and snow, were once at the bottom of a deep sea. How is that even possible? Well, in this explainer, we will find out exactly how this unbelievable transformation happened. So let's start at the very beginning. Chapter 1 of our story is about the mountain's fiery birth. We'll explore the huge, cataclysmic collision that gave rise to these giants. Now, what's really interesting is that, in geological time, the Himalayas are actually very young. You see, unlike the ancient and stable peninsular plateau of India, the Himalayas are still active and growing. This youth makes them an unstable zone because the massive forces that created them are still at work, pushing them a little higher even today. So how exactly did they form? Well, geologists call them fold mountains. The best way to understand this is to imagine pushing a tablecloth from both ends. You see how it wrinkles and folds upwards? Something very similar but on a much grander scale happened here. For millions of years, the Indian tectonic plate was slowly moving north until it crashed into the huge Eurasian plate. The immense pressure squeezed all the soft mud and sand, the sediments, from the ancient Tethys Sea that was between them, causing it to buckle and lift up, forming these massive mountain folds we see today. Now, it's important to remember that the Himalayas are not just one single mountain range. No, they are a massive system made up of three distinct, parallel ranges that run alongside each other. Let's explore the structure of the Himalayas, starting from the highest range and then moving downwards. First up, we have the northernmost range. This is known as the Himadri. You can think of it as the main backbone of the entire Himalayan system. The Himadri is the most continuous and the tallest of the three ranges, with an average height of a staggering 6,000 meters. It is always covered in snow, which is why it's called Himadri, the abode of snow. This is where you will find all the giants, the most famous Himalayan peaks like Kanchenjunga. And deep inside, its core, its skeleton, is made of very hard granite rock. Now, if we move just south of the Himadri, we find the next range, the Himachal, which is also called the Lesser Himalaya. While it's not as high as the Himadri, this is considered the most rugged and complex part of the mountain system. The Himachal range is mainly made of highly compressed and altered rocks. Its altitude varies between 3,700 and 4,500 meters. This range is very famous for its beautiful valleys, such as the Kashmir Valley and the Kangara and Kulu valleys. In fact, many of our well-known hill stations are located right here. And finally, we come to the outermost range of the Himalayas, the Shivaliks. These are like the rolling foothills that form the southern boundary of this great mountain system. The Shivaliks are made of something called unconsolidated sediments, which is basically loose gravel, sand, and mud brought down by the rivers from the higher Himalayan ranges. A very special feature here are the long valleys that lie between the Himachal and the Shivaliks. These are known as duns. I'm sure you've heard of Dehradun. That's a perfect example of such a valley. All right, so let's have a quick recap of these three ranges. We have the highest granite-cored Himadri with its glaciers and massive peaks. Then we have the middle Himachal, which is known for its compressed rock and its beautiful valleys and hill stations. And finally, the low-lying Shivaliks, formed from river sediments and featuring those special valleys called duns. Okay, so far we have looked at the Himalayas from north to south, but we can also divide them in another way, from west to east. So now let's take a journey along the entire 2,400-kilometer-long arc of these mountains. So the important point to understand here is that these west to east divisions are marked by major river valleys. You see, the great rivers have cut deep gorges through the mountains over millions of years, and these gorges act as natural boundaries for these regional sections. Let's trace this journey together from west to east. Starting between the Indus and Sutlej rivers, we have what is known as the Punjab Himalaya. As we move eastwards, the part between the Sutlej and Kali rivers is called the Kumaon Himalayas. The next section, between the Kali and Teesta rivers, marks the Nepal Himalayas. And finally, our journey ends in the east with the Assam Himalayas, which lie between the Teesta and Dihang rivers. Now our journey across this arc takes a dramatic turn. At the easternmost boundary of India, the Himalayas don't just stop. They do something very interesting. They bend sharply to the south. This southern extension is known as the Purvachal, or simply the Eastern Hills, and they run through India's northeastern states. Now, unlike the main ranges, these hills are mostly made of strong sandstone, and they are covered in very dense forests. The Purvachal itself is made up of a series of parallel ranges, including the Patkai Hills, the Naga Hills, the Manipur Hills, and the Mizo Hills. So we have seen how the Himalayas were formed and what they are made of. But finally, let's understand why they are so much more than just mountains. They are truly a lifeline for the entire Indian subcontinent. First of all, their great height and length create a massive climatic barrier. Think of it like a giant wall. This wall protects the subcontinent from the freezing cold, dry winds that blow from Central Asia. It also acts as a crucial barrier for the monsoon winds, forcing them to rise, cool down, and release all their moisture as rain across India. The Himalayas are also called the water tower of Asia. All their vast glaciers and snowfields are the starting point for our great perennial rivers, the Indus, the Ganga, and the Brahmaputra. Perennial means they have water all year round, and they provide a constant supply, supporting millions and millions of people and vast ecosystems downstream. And you know, it is these very same mighty rivers that have shaped our history. As they flow down from the mountains, they carry and deposit incredibly fertile soil called alluvium. Over millions of years, this slow process created the huge northern plains of India. These plains not only became the food bowl of the country, but also the cradle where great early civilizations could grow and flourish. And so we end with this final thought. The Himalayas are geologically alive. Remember, they are still rising, inch by inch. It really makes you wonder, doesn't it? As these young mountains continue their slow but steady growth, how will they continue to shape the land, the climate, and the lives of everyone on this continent in the future?